So from Monday's assignment, evaluating expressions in a single variable. What we're doing here is we're replacing y with what it's equal to. So for example, instead of saying y plus 2 squared, this becomes negative 4 plus 2 squared. From here we follow the order of operations. The first thing we do is what's inside of the parentheses. If we take negative 4 plus 2, we get negative 2. And then we square it. Negative 2 squared is the same thing as negative 2 multiplied by negative 2, which turns out to be a positive 4. The next problem, we replace v with what it's equal to. Oftentimes I find it helpful to use parentheses. It helps us keep track of that we are multiplying and not adding or subtracting. So here we have multiplication and subtraction. If we follow the order of operations, the first thing we do is multiply. So this gives us a negative 20 minus 3. And since we are subtracting from an already negative number, it brings us further negative to negative 23. Let's jump around a little bit. So here's another example problem. We replace the v with a negative 4. Then we follow the order of operations. First thing we do is parentheses. It becomes 5 times negative 3. And then we do the multiplication to get negative 15. Let's take a look on the back from Monday's assignment. How about this one here? We're going to replace t with what it's equal to. So it becomes 4 times negative 10 minus 2. The whole thing divided by 3. Since this fraction bar is underneath that entire quantity, there are actually invisible parentheses here as well. We start with the innermost layer of parentheses. The first thing we do is negative 10 minus 2. And this becomes, write it up here, 4 times negative 12 all over 3. Following the order of operations, the next thing I do is the multiplication on top. 4 times negative 12 gives me a negative 48 over 3. And since I have a negative divided by a positive, I know my answer is going to come out negative. And it turns out that number is 16, negative 16. Let's jump to Tuesday's assignment. We'll go through a few problems. The question was, how did I get the 12? And the answer is, I started with a negative 10, and I went 2 further negative. So that's why it became farther negative rather than 8 or something like that. Yes. You can think of subtracting 2 as the same thing as adding a negative 2. From Tuesday's assignment, we'll do just a couple. We plugged in, for example, 10 in more than one spot because the variable u showed up more than once. So this became 10 minus 10 cubed, for example. Again, we follow the order of operations. This becomes 10 minus 0 cubed, which is the same thing as 10 minus 0, which is just 10. Let's jump down a few. So here we have 5 divided by x plus 4 cubed at x equals 1. We replace x with what it's equal to, which is 1. And then we follow the order of operations. We start with the innermost layer of parentheses, which is 1 plus 4. And this becomes 5 divided by 5 cubed. The mistake that a lot of people make is they want to do the exponent earlier than they should. Remember that all of the parentheses have to be resolved before we do the exponent. So in fact, we take 5 divided by 5 before we cube anything. And this gives us 1 cubed. And that means 1 times 1 times 1, which is still just a positive 1. Let's jump down to the bottom right here. The new thing with this problem is that we are replacing 2 variables. So you have to match up the u with what it's equal to, which was 10, and the a with what it's equal to, which was 1. So we start with the layer of parentheses first. 1 squared is just 1, because 1 times 1 is 1. We multiply by 1 again, and it's still 1. So we have 10 divided by 1, which is just 10. Let's look at the back of Tuesdays. Do a couple problems here. How about 7 minus 6 times the quantity v squared minus v, for v is equal to 3. So the first thing we do is we replace every instance of v with a 3. Then we follow the order of operations. Inside the parentheses, we do the exponent first. So this gives us 7 minus 6 times 9 minus 3. Then we do the subtraction that's inside the parentheses. So we have 7 minus 6 times 6. Then we have subtraction or multiplication. Which one do we do first? Multiplication. Good. So it becomes 7 minus 36. And 7 is positive, but if we go to the left 36, this brings us way into the negatives. In fact, at negative 29. We'll do one more from this page, and then we'll jump to Wednesdays. So if we plug in 5 minus 5 times 5 to the 4th, because we were replacing y each time, the 5 minus 5 gives us 0. And then we have 0 multiplied by 5 to the 4th. So 5 to the 4th might be a little more difficult to figure out. 5 times 5 is 25, times 5 is 125, times 5 is 625. But it doesn't matter, because we're multiplying by 0. Anytime you multiply 0, the answer is always going to come out 0. Let's jump to Wednesdays. Harder expressions in multiple variables. We'll start with the box here. We plug in 9 for z, and this becomes 9 minus 1, times 10, divided by 10, plus 4. We replace z with 9 and y with 4. The first thing we do is the parentheses. This gives us 8 times 10, divided by 10, plus 4. Remember that multiplication and division happen at the same time, so we just go from left to right. So the first thing we do is 8 times 10, and that gives us 80. And then we divide by 10 plus 4. And the next thing we do is 80 divided by 10, which gives us 8 plus 4. And when we add those together, we get 12. Let's do another problem here. C to the 4th power plus 12 minus 3 plus v at c equals 2 and v equals 4. So we replace c with 2, and this becomes 2 to the 4th power plus 12 minus 3 plus 4. So a lot of people are seeing 2 to the 4th power, and they're thinking 2 times 4 is 8. But in fact, 2 to the 4th power is really just 2 times 2 times 2 times 2. We are multiplying 2 by itself 4 times. So if we take that one at a time, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this 2 to the 4th is replaced with 16. Addition and subtraction happen at the same time, so we simply go from the left to the right. And this gives us what, 29? Yeah. We'll do maybe one more from the back. Let's see here. How about this one? 10 divided by 2 times 7 divided by v times 5 at v is equal to 10. So the only change is that we replace v with 10. And all of the operations are either multiplication or division. The mistake some people are making is they think multiplication happens before division, but that's not true. They happen at the same time. So you go left to right, and we start with 10 divided by 2, and we get 5. And we'll carry the rest of the problem down. Then we start with 5 times 7, which is 35, divided by 10 times 5. So 35 divided by 10 is 3.5 times 5 is 17.5. Weren't there some fraction ones? I vaguely remember there being some fraction problems. Is this the assignment? We'll start with the top right and see where that takes us. So here we have 3 minus 9 minus 3 divided by 9 divided by 3, and we're missing a parenthesis there. Inner layers, 9 minus 3 gives us 6. 9 divided by 3 gives us 3. So then we are left with 3 minus 6 divided by 3. First thing we do is the division. 6 divided by 3 is 2. 3 minus 2 is equal to 1.